first session of afternoon. You will have a lecture on DID model for impact analysis using Stata software. This lecture will be taken up by Dr. M. Balasubramanian. He is a scientist in agriculture economics and posted at Division of Agriculture Economics, IRI, New Delhi. He joined our ICS system in 2016, and since that he is working at IRI, New Delhi. And his area of specialization is natural resource economics. Welcome, sir, to this training.
Yes.
And we are very thankful for your joining and giving lecture to our participants. Now, we request you to please deliver your lecture, please.
Thank you. So, thank you very much, sir. Thank you very much. Yeah. Shall we start, sir?
Yes, sir.
Yes, sir.
Yes.
Share your slide first.
Sir, is it visible?
Yes, sir.
Okay, sir. Yeah. It is now.
Yeah. It's
Yes.
So, very good afternoon to all the respected participants, and I'm welcoming for this winter school training on analytical techniques for decision making in agriculture from this 5th February to this 25th February. Maybe the last day of you're nearing about the last day of this school training. Yeah. Today we are going to see the difference in difference model as one kind of impact evaluation tool. Okay. Using Stata, and we can. I'm going to use Excel also, and we'll see. Yeah, the first one, the tools for impact evaluation. First of all, there will be the budget allocation and the target setting. So to find whether the scheduled plan is achieved, the plan allocation, then the next step goes to the inputs, then the next step for output, then the next step will be the outcome, then finally the impact. Okay, this is not in a year period. It may take 2 years also or 3 years also, depending on the program or the objective what we are having on our hand. Okay, so some few techniques, the financial outlay, the discontinued budget techniques could be found without using any separate impact tools. Okay, and some technological interventions must be needed. Some kind of impact tools like random evaluation method, propensity score matching method, and DID model or regression discontinuity model. Like it depends on the interventions what we are making. Right? And the third factor is time. During the time period, it is some few variables are variant and few variables are invariant. And these invariant characteristics, for example, the technological development and this general growth aspects of the economy or region, where we are going to study. So these aspects, it will be covered when we use some kind of a tool to assess the impact. And in this time factor, the time fixed effects, some variables, fixed effects could be taking some qualitative factors, outcomes, which we take as our objective. Then the time fixed effects model will be very useful, and without. And time invariant effects will be the before or after, pre and post time period, how to evaluate so that we can be assessed. And interaction between these two groups, this time fixed effects and time non-fixed effects, will be assessed through this this model. So come for this, the impact evaluation. Of course, this impact evaluation is to find a missing data. Why I am telling this missing data? Because one could not observe the outcomes of program participants or interventions had they not been as a beneficiary. If they may be the participant after the intervention, then we can output. But the missing data here is what they were if the program is not earlier. So that is the one. And here the perfect term here is the without information on the counterfactual. The earlier data on the beneficiaries. If the earlier data is very correct, then the impact what we are going to use or assess will be, we get more accurate, inaccurate measure. Okay, so the next best alternative is to compare outcomes of treated with non-treated. Okay, and the successful impact evaluations always has hinge on finding a good comparison group. Okay, to find a good comparison group or a good counterfactual group. Okay, here you could know that counterfactual I'm using, that counterfactual, what it is, what does it mean? A beneficiary's outcome in the absence of the intervention would be act as counterfactual, right? In any impact evaluation programs or interventions or policy aspects, right? So the challenge here is to find the appropriate counterfactual. That is, to find that we have a two kind of methods that create a comparator group through the statistical design. If we can, through this sampling methods, we can manage. Okay. If could not, then we have to alter our target group. That's the second strategy. Okay. How to alter the target strategy itself, we have to change. That's a very bigger challenge. Okay. So come for the basic impact evaluation equation, which shows here that y is the outcome is equal to alpha xi plus beta ti plus epsilon I. That error term. Okay. Here the beta, alpha and beta are the coefficients. Okay. And xi is the observed set of the characteristics of the sample. Okay. And the t is either dummy, whether the t is treated or non-treated. Okay. If t is a 0, then it may not be the intervention, before intervention or without that intervention. We can take it in this two way to can interpret. Okay. And T1, it indicates that when the intervention is happened with the participants. Okay. And it obviously this equation gives this direct effect. The outcome will be the maybe our increase in the yield, income, whatever the case, whatever we are keeping it, fine. Okay. Now this, it can be the direct effect we can catch, the direct effect which could be catch from this in simple analysis. The indirect effects, to find these indirect effects, that is the most phenomena to get an accurate figure for our analysis. Okay, because this indirect effects which is influenced by the external factors. Okay, so up to the certain level, we may have control on these external factors. How much control we are having these external factors, that much level we could control our experiments, then we can get our results as most accurate, right? So for this, reducing the influence and the errors, we are following different types of the impact evaluation tools. Okay, and the most one is the impact evaluation of the program, of a policy. Obviously that it coins that it has already the purpose where the program is implemented, where the kind of a policy can be used, and in which area it is. It's the locality, it's already a purpose. Okay, where the project going to be happen, and what are who are the stakeholders and who are the beneficiaries, and how and where those questions can be answered through, because of this purposive nature, okay, the purposive placement of any program, okay. Then the self-selection. Of course, this self-selection is based on the observed factors in the field, okay, and this may be some kind of unobserved factors also, okay. To reduce the error with these unobserved factors, how we are reducing these unobserved factors in our analysis, in our equation, that gives the results more accurate, right? Okay, so this, if you are not touching this one, it leads to the selection bias. Okay, it selects to the because the program is the intervention make of any seed variety, new variety, which is have a very good yield and has a good campaign awareness programs happening through this extension official workers to evaluate the impact of this newly developed seed. Then the perfect region where that's suitable, might be the purposive. And the next point, the group of people, the sample or the farmers going to be use this technology, that has to be taken. Here, the unobserved factors are even within those who take the seed to put in their field, that also within them also, or those who would attend the training and may not want to use this new technology. So there will be the difference between with and without also, and between these groups also we have a difference. So for that, the before and after approach is needed. So combining both with the intervention, without that intervention, and before the intervention happen, what will be the targeted beneficiary, and after that intervention, what the beneficiary has. So combining these two perspectives, there is a major or factor behind this double difference method, right? Okay, and so before that, there are, I said already, there are many impact evaluation tools are there, like PSM, the propensity score matching, and randomized evaluation techniques. And more than that, the combining of double difference and PSM, and then after that, we can go for instrumental variables, regression discontinuity models. There are different. So I said, in the PSM model or this randomized evaluation techniques, we use only the single difference estimators. Okay, single difference estimators will be used. Either it will be the with or without, or before. Okay, but in here we are using the combination of both. Okay, so the data itself here, there in earlier forms, they may use the cross-sectional data. Here we are going to use the panel data also, right? So that is the one of advantage to apply this double difference model. Okay, the panel data, of course, you know the criterion for a panel data. Okay, and in this DAD, whether only the panel data can be used, whether cross-sectional data can be used or not. Yeah, we can use this model in the cross-sectional studies also, where the repeated cross-sectional data can be used. Okay, so not a single point of time, that repeated studies of this cross-sectional studies can be used to compare. Okay, to evaluate the particular group. There also we can use this difference in difference. Find it. So now in this model, the basic equilibrium, the equation here is the expected E of y1t minus y0t over t1 is equal to 1 minus E expected value of y1c minus y0c over t1 is equal to 0. Whereas the capital T indicates the technological interventions, which I have said already earlier. One indicates after the intervention, that T1 is that 0, it indicates that there is no technology intervention happen. Okay, and T and C are the treated group and the control group. Control group is nothing but the non-treated units. Okay, this is a simple equation of this double difference method. Okay, now we are going to see by the graphically and this with estimators also, how to develop the estimator also for this equation that we are going to see here. Here, that I said already in the previous two methods that PSM particularly, there might be a chance of the unobserved heterogeneity. The character may arise. Okay, this what is meant by the unobserved heterogeneity? This is nothing but there may be an unobserved difference in mean counterfactual outcomes between the treated and non-treated. It may be available. Okay, that can be captured, and that unobserved heterogeneity, the role of the unobserved heterogeneity will be taken care in this double difference model. Okay, because once if you could not do this, then it may lead to the selection bias. Okay, if the selection bias happened in your sampling and your in a evaluation program, then maybe our objective would not be achieved. Okay, to achieve this, we have two fundamental assumptions we are. The first assumption is the unobserved heterogeneity is the time invariant and uncorrelated with other variables. Very strongly, that unobserved heterogeneity is time invariant. That's a basic fundamental assumption we are having here. How this assumption gets valid when we, that can be seen from the next slides. Means through our estimator, when we find for an estimator, that then this first point you may get an idea on why I am telling this particular point. Okay, this unobserved heterogeneity, it will be nullified. Okay, right? And the second assumption is availability of the baseline data. This is the foremost point which is needed to calculate, to apply double difference model. Okay, the baseline data is nothing but the situational analysis survey, kind of the broad structure or broad view over the sampling region, or else the samples. Okay, we have bird view over the about the samples. Okay, either it's a households or a farmers or a kind of a wage earners or whatever target group we are having, whatever it is. The baseline data, which because it serves as a fundamental tool to compare the two groups. Okay, either it is a control group or it is the beneficiary group, treated group, whatever it is. So the baseline data is foremost needed here. Okay. And if the assumption is not hold, the baseline data is not there, even though the chance, yeah, it may be a chance, but we have to use another method. Okay, that is it. Okay, that what the reviews, those who were applied and empirically successfully have done. Then the first in historically double difference method used by Snow in 1854. Okay, where he has that whether the cholera was transmitted by the bird, air, or bad water. He has supplied a different quality of water in two districts. Okay, in London that survey was happened. Okay, then he found that water which is through the contaminated water where he supplied, it has more chances of spreading cholera. He found it. Okay, there must be that. Then Rose in 1952 and Lester in 1946. Lester, what he had done, that effects of wages on employment in labor market. Okay, how this wages affects. Okay, how the migration of this labor and this increase in the labor wage, higher wage and lower wage. Okay, higher wage and lower wage. Okay, with and without here. That he has assessed and how it influences the migration of a labor, that he find it through this through his studies. Okay, then Rose about this effect of a mandatory mediation on work. stoppages. Okay, means comparing the status with the law, without the law, means that before the law intervention and then after. In likewise, he was used with this one. And this Assenfelter and et al. Group, the effect of immigration on the local labor market, like how Lester has done in elaborate study he has made in US. Okay. So now come for this, how to implement this double difference. Okay, how to address this, what is mean by counterfactual, how to address this effect here, that we are going to see. Okay. Here you just see here in the diagram, the left hand side, the income that is on our targeting our objective. Okay, it may be the increase in the income level or yield level, whatever it is. Okay, that we can, it's in be the in y-axis. Okay, and in the x-axis it is, in x-axis it is written as the time factor. Okay, the time factor which indicates that the vertical line splits that the before the participation, then after the participant, what is the level of their income. Okay, that it can be easily get. You see here that the lowermost line, the y naught, indicates there that is a true counterfactual. Okay, that is a true counterfactual line, the y naught. Okay, then that there may be the difference between the control group and different, that the control group income level is y1. Okay, that y1 before and after. Okay, and the participants, right, the participants, what they were having, this their earlier income before the before the program was implemented, then after the program implemented, that's in another line it can be given. Okay, and here you can have the difference that, so the double difference is, I said already, the average difference in outcomes of separately from the control group and treated group. Just to first point, we have to do that. The average difference in outcomes of the participants and non-participants, are those who used this technology, are those who not used that technology. Separately, we have to take an average difference, okay, between these two groups. Then the next level will be the difference between the whatever the value comes now, that difference gives our DD, that double difference. Understand? That taking an additional difference between the average changes in the outcomes for these two groups. Okay, which gives you our final figure. That's I have given here the first equation. That's y4 the level minus y0. Okay, minus y3 minus y1. This is the double difference. Okay, because this figure gives you the one difference, and this another term y3 minus 1 gives the another term. Okay, this is the participant, this is the non-participant. Okay, whereas here the y3 minus y2 is equal to y1 minus y0, because it is the counterfactual. How I am the difference you may see here, the unobserved heterogeneity is time invariant, I said already. So the level which is altering from y2 to y3, if you find a difference between the y3 minus y2, this is not your correct impact study, because you're underestimating your program. Okay, the difference is same as y3 minus y2 as same as y1 minus y0. Okay, that is here written very clearly. The y3 minus y2 is equal to y1 minus y0. If I apply this equation, this equilibrium equation in the previous, I'm getting that y4 minus y2 gives the original impact of the program. Okay, that is nothing but our double difference. Fine. So now this, of course, by graphical we have done. Now come for this estimation through this by the making a regression equations, how we can model the outcomes. Okay, that's I have given that y I is nothing but our outcome is equal to alpha plus beta ti plus gamma t small ti plus delta into ti into ti plus epsilon I, that error term. Okay, see here, the capital YI is nothing but the outcome. Okay, outcome of the sample, okay, whether it is whatever that. Okay, the alpha denotes the constant term. Okay, the beta, okay, that beta here, which is denotes the treatment group specific effect. Okay, this is nothing but even your earlier equation I said, no, that to account for average permanent difference between treatment and control. See, if you are taking this sample as in here, if you are considering this, the difference is considering this y0, y1, if you are taking this is your participant, this is your control, this kind of some kind of a permanent difference is there. Okay, that is observed in the characteristics itself, there itself. Okay, this is not because of any technological interventions. Okay, this difference is already existing. That is that beta, treatment group specific effect. It may be lower or it may be higher, whatever it is. Okay, and that the next coefficient is gamma, that is a time trend. Okay, that is common to both control group and the our treated group. Fine. The delta is our final one, that is that final coefficient which explains about the true effect of the treatment. Understand? Because it is the combination of both the treatment and the time. Okay, that it's not a combination, it's the intervention between the technology and time. Okay, which both are how deciding our output. Why? How influencing? Okay, so which is influencing the all other. Okay, the true effect of the treatment comes from this delta. Okay, fine. Oh, sorry. So to have this equation, to find this unknown, these four unknowns, we have some assumptions. Okay, so there earlier one assumption we had to by in graphical. There we are having another three assumptions. Both are same. Okay, I am explaining here. Okay, here you see here the 1 second here. I think this goes to yeah. See here, this assumptions of an unbiased estimator. The estimator will be the good estimator, then which is unbiased. It means that the average estimate will be the correct, the basic criteria for a good estimate. Okay, so the expected value of delta, the cap, that cap hat has to come. Okay, delta hat is equal to simple here without bracket gives our delta value. Okay, when this value is that average value is okay, then that estimate the delta here is okay, we can consider. Okay, that next one, the model in this equation or that is correctly specified. In the correctly specified, what it doesn't meaning here, the additive structure of each individual components must be explained. So additive structure must be exposed. That is the first one. Of course, in the equation, what we have seen here, that additive structure is exposed clearly. Okay, the error term is an average 0. This is nothing but average value of the error term must get 0. This is not hard assumption. Okay, because if at all any other influence is there, that can be explained through the alpha term also, the constant term. Okay, understand? Okay, now the third one, the error term is uncorrelated with the other variables in the equation. This is the one which have your fundamental assumptions there. The unobserved heterogeneity is time invariant, I said already. So that is both are same here. Okay. The error term of the technological intervention or the time trend, both are uncorrelated. Okay. If it is correlated, then your sample will be, we have a character of unobserved heterogeneity. Okay, where your time means where this may not be invariant, it may be variant. Okay, because here the both individually technology and time both are individually with error term, and combination of both has a relation with error term also, there is no correlation. Okay, that is this assumption we can call in another name parallel trend assumptions. Okay, to have our value is to have our the equation gets valid, that the parallel trend assumption must get true. Okay, so to apply these assumptions in the earlier equation what we have seen, now we can derive our unknowns. Okay, the first I said in the here the basic equation, here you can see this, the double difference one. This is nothing but treatment with the counterfactual. Okay, y1t minus y0t. Before the treatment, how the participants itself differing, and before and after, how the control groups get differing. Okay, the difference between these two gives our double difference, I said. Okay, so applying this, the expected value or average of this y0t gives alpha plus beta. Understand why here alpha plus beta? Alpha is common for all. Why it is a constant term in the equation. Okay, then y0t, t is I said already, t is a technological factor. That's you can t. T is a technological factor, so that coefficient come here. Okay, and for y1t means after intervention. After intervention, what are the factors it can affect? After intervention, that there are two more coefficients are added here. This is the gamma, which indicates the time factor, and the delta indicates the actual combination of both time and this technological intervention. Okay, and expected value of y0c, this is our basic counterfactual. Okay, that is the taking of this error term is 0, then it gives only the alpha. Okay, that is only the alpha value, right? Applying this above assumptions. Then the another one, after treatment, after intervention, what will be the expected mean value of the control group is equal to alpha plus this time trend, because there is no technological intervention. If the technological intervention is not there, then there is no use of no value of this delta. Okay, so you understand how these four different explanations by using this assumption, how it is arising, because from this we can derive our final equation. Okay. Okay. See, before going to this final, so now I'm comparing with simply with comparing the two parameters. Okay, that's simply with the participant before, after, pre and post estimator. Okay, that is our next time. The estimator I'm going to find here. Okay, that estimator here DD1 I am taking because only one unit. Because before and after, how the participant group or treated groups average difference gets, that I am going to deal here. Okay, that expected delta 1 is equal to y1 bar t minus y0 bar t. Okay, so this one is technological intervention. The 0 indicates the before the program or after the program we can. Okay, so you applying this two factor here, we can get alpha plus beta plus gamma plus delta minus alpha minus beta it comes. Okay, if you apply earlier notations here in this equation, the final equation comes as, you may see here, the gamma plus delta it comes, whereas it may not give your original effect, because this is your true treatment effect. This is your time trend you are added here. Okay, then what will be the answer? What will be your result tells if time trend exists, it being part of your impact effect. Okay, so this may not be give your exact impact. This impact combined with your time trend. Okay, then if you take the another one, simple another step with control and treated directly with y0 with y1 with y4 in the diagram what I have explained in the previous. You see there that DD2 what it gives, y1 t bar minus y1 bar c. The directly the effect of the here only the treatment is the only effect. Okay, what how then the if you give the notations earlier, substitute those, then you may get beta plus delta. Okay, here it may be overestimated or underestimated. Why? Because this beta is the your intervention factor. Okay, impact of your program. Okay, so now combining both with pre and post and with and without, but combining both, I'm developing a third equation. That's a difference in difference. Okay, applying all notations as early. Okay, y1 t bar minus y0 t bar minus y1 c minus y0 c. Okay, which is denotes the your technology and both control difference. Okay, and where your time factor and your technological interventions both will be subsumed. Okay, both will be deleted, or both the role get be included. Okay, the effect of your program will be catch through exact figure. Okay, that is the advantage using this double difference. Okay, that I'm using only a single estimator earlier, then it may be overshoot or undershoot because of these two factors. Okay, and this results I have presented here in the below the table. You see here that where this in the row the treatment and control and the difference between the treatment and control, whereas in the columns the before program and after the program. Okay, the pre intervention and post intervention, and difference between these two as another next column. Okay, the first one treatment y0 t, y0 bar t I have mentioned here, and there y1 t after intervention. Okay, because it is the treatment, this is treated. Okay, and difference between these two, y1 t minus y0 t. Okay, and the next one, that control, that is y0 c bar and post after intervention, so after some point of time where we are taking data, y1 bar c it is y1 c minus y0 c. Okay, just to subtract from the by row and column wise, you have the similar the basic equation what we have seen in earlier slide. You will get it. Okay, understand the difference between this and difference between these, and you see here that the final difference will be the y1 t bar minus y1 c bar minus Y0T minus Y0C. This is nothing but that before intervention, after intervention, the difference between the treated and control. That is the final column in the table. Interprets. Okay, fine. And this simple technology, the tool will be used in one of my research work. Okay, that I am going to present now. Where adoption of water management technologies that I have, that water management technologies. There are three water management technologies developed and given campaign on awareness given by the IUMI, International Water Management Institute. Okay, in the Nagarjuna Sagar project. Okay, Nagarjuna Sagar area, the dam area. Okay, what is the impact I'm going to assess? Okay, applying this DD model. Okay, so this introductions about that program. Okay, how this program gets formed. Okay, that CLAIMA Adopt is the major funding program for this study. Okay, so it may not be needed for your here that the point just to see here what are the most adoption strategies what we have followed in this model is use different crop or different crop varieties or the different tree or soil conservation or changing planting dates or water saving irrigation practices. See here why I mentioned these 5 or the adoption strategies. It comes from our baseline data. I said already the fundamental, I said, do you remember the assumption I said? One of the assumptions to have the DD model is the baseline data availability. So under the CLAIMA Adopt program, they have a complete survey over the Nagarjuna Sagar project area in Andhra Pradesh and Telangana. Okay, so wherever that the area covers, they have a very exclusive study over the basic characteristics, okay, of the region, people, administration, at all the points they studied, and based on that, they developed that these are the different kind of adaptation strategies. From these adoption strategies, we are following what we are taking as a technological intervention as water saving irrigation technologies or water saving irrigation practices. Understand how to develop first of all your program. It may be the holistically you have to develop first. You have to find what is the gap is there. Based on that, you may plan for some program. Okay, you may planning. Then the program where it will be implemented in that the area you have a thorough idea that it gets through your baseline study or situational assessment. Okay, and these are the supporting from the Indian Council of Agriculture Research and SAUs in these 2 states and international institutes. I said already that ICRISAT and IWMI, International Water Management Institutes. Okay, they were formed, helped to go supported for this study. Okay, so that what are this water irrigation practices from this here from that is maybe the 3 more water saving practices are there. Before that, the situation analysis of baseline data I said now what are they were covered and what they got that I have mentioned here. Okay, the situation analysis was carried out for the study areas and found that farming practices, water insurance, capacity building, gender information services, and the earlier said areas. Okay, to address this, the overall objective of this climate change. This is nothing but the use of less water. Okay, less water. That is our focus. Okay. So what are the adaptation practices, water saving irrigation practices? That's one method is a direct seeded rice, DSR method, and modified SRI method of cultivation, that mechanized transportation of the rice. That's nothing but the modified SRI, okay, system of rice intensification. Then alternate wetting and drying method. Okay, the other other adaptation practices, what they have went through it, the green application of green manures, and those who had this weather index have not taken these two parameters. For our study, we are having only these three. Okay, how these three are influencing. The target variable here is to use these three interventions and how the yield difference. So my target here is yield level of the farmer. Okay, so basically focusing on the rice. So the rice yield is taken as our objective, increase in the yield level of rice. Okay, there's a few pictures which is in the field we have taken. DSR method, how the direct sowing of rice, that's such nothing but direct seeding rice. Okay, and MSRI, okay, that mechanized transplantation, okay, in this system of rice intensification system. Then alternate wetting and drying method. Okay, these three method. This alternate wetting drying method is to find when you have to give irrigate in the field. Okay, that's a plastic perforates tube. We have to pick in 1 acre area. We have to plant, yeah, almost 6 to 20 number of this perforated tubes has to be installed. And if this the in between within this perforated tube, if you the soil which is dried, then you have to irrigate. So accordingly, you are saving water. Okay, that's our objective. Okay, so this is our hypothesis here is the capacity building, the awareness program on this water adaptation practices. Okay, and this how to implement, who were implemented in their field. Okay, to reduce the water use, cost of cultivation, and improve the income of the adapter workers. That is our hypothesis. Okay, whether this capacity building and the participation which reduces the water use or cost of cultivation or increases the income. That is our study. This project area is in this to Nalgonda from Telangana and from Guntur district. 2 districts were taken. Okay, this total from each the totally the Nagarjuna project, that's nothing but Krishna River basin in this line. Distributed canals. Okay, there are more than 40 distributed canals were there. So we have taken from that, we have chosen randomly chosen DC4 and DC21. Okay, and in these two, this is again randomly chosen, but within the random selection, you may have a purpose. Okay, where you are implemented your project, where you are given your awareness training programs or capacity building programs. Okay, so have mind on it always. And field level will be the in field level, this is taken as random sampling in the area. Okay, completely we can have a list of the beneficiaries, those who are attended, not attended, the attended with, not attended with, implemented. Kind of a survey happened, and from the list, the random selections were made. Okay, and non-adapters from the 2 distributory canal, each canal they have selected. Okay, and this is a total sample size of 178. It comes totally. Okay, and that's in these 2 districts I said already. So using this double difference, we are going to adapt this, how this technological the improvement because of this water saving intervention, how our output gets increased. Okay, that we are going to see here. So see this diagram from earlier your explanation. This left hand side I have taken the outcome. Here outcome is yield. That in the x-axis is a time factor, I said already. So here is a starting, before implementation and training, and after implementation and training. So here the basic line is the fundamental line is the true counterfactual line. It denotes the true counterfactuals before implementation and from the control non-participants. Okay, and these are the control group, their yield level, and this water saving interventions. After water saving interventions, what is the yield level? Oh, sorry, you can see this. Okay, from the graph you can identify. So the difference between these two gives, this gives the control groups before and after, and this figure gives treatment group before and after. Okay, and you are now seeing here here after adopting water saving interventions method, adopters are D1, non-adopters control group C1. Okay, and before adopting they're D0 and non-adopters C0. Okay, the difference between these two, it is written here. Okay, and the double difference which I mentioned here is D1 minus C1 minus D0 minus C0. Fine. Oh, I think it gets stuck up system. Another sir, my dear participants, my slide got stuck up.
Yes, sir.
Please wait for a few seconds. It gets roaming up.
Okay, yes.
It's rotating.
Sure, sir.
And between that, one doubt I have raised that baseline data also collected from control group farmers. Yes, yes, sir. It is the baseline data when the which includes control farmers also. That in chat box they have written. Oh. So, I think charge it. Sir, sir, Sally, stop share and I'll share again. Sir, technical fault, sir. I'll be sharing again, sir. Within another few minutes, I'll finish.
Yes, sure, sir.
Oh. they estimate how we assessed from the last our earlier equations, whatever the estimates we find, now we are going to apply here. That's the y1, y0, the same thing, the with before intervention, and the difference between the before intervention then with control y1c minus y0c, that is that one. Okay, and having the impact, the final y1 yr1 cap minus yr0 minus yc1 cap minus y bar c0. Okay, here r1 where they have kept here the participants, there c is a control. Okay, that equation which we are get, okay, without error term, the a alpha plus beta, a plus b I have given here, that a plus b plus b, this delta plus cti plus combination of both. Okay, in earlier equations I have given a different terms for each one. Here I have given the different coefficients here. Okay, there alpha, here a plus beta in the sense here b. Okay, that's the only. Okay, the other things are similar here. So this time trend, this is taken in the capital T. That small here, it is a technology. Okay, that's a delta symbol. So control group before the program, in both the way it's a like same result like alpha. Here it's a. Okay, and control group after the program, because there is no technology, so 0, and after the program 1, a plus c here, a plus c here, and trained group before the program 1, the technology before, so they are 0, a plus b only, and trained group after the program in both the columns it is 1 1, and a plus b plus c plus d. Okay, this last terminology d is our original double difference. Okay, so based on it, we were given a results. We were making the estimates. Here you may see the average difference of mean difference. That nothing but the yield difference between these two groups, adopters and non-adopters. Okay, and control group farmers before the program, control group farmers after the program. Okay, that's and the same you may see for 3 different set of adopters, 3 different technology adopters. Okay, you may see here, and the net impact of the yield you may see which one is significant here, that you may get it from the regression analysis. Okay, here this is a technology, this is the time factor. Okay, and this is your combination of both technology and your time factor. Okay, you may see here the combination of both the technology, or the technology here is nothing but the capacity building program on the water saving interventions, those who have participated, with the time factor. You see the combination of all gets significantly, it shows significant. Okay, so the intervention done in this area, it has some significant, it has impact over our objective is the yield level. Okay, so whatever we get, then that is our hypothesis gets satisfied. Okay, so that is the result I have shown here. And this measure is a very simple and appropriate method in capturing the yield increase or any kind of our objective. We can use in this here, we can use this stool here. Okay, and this is the code for the double difference method I have derived. Okay, and if you apply this code in this Stata, you may get the results, and you can get it from the Excel also. Sir, I'm sending this Excel file. Okay, and this Stata file also. Okay, and if at all, if you have any kind of clarification, then let me write to my mail. I'm pleasure to write your replies. Okay, so you see, sir, do you visible this Excel sheet?
Yeah, it's
No, sir. First, you answer your close your PPT.
Okay.
Dr. Vikas, is it taking time?
Yes, yes.
Uh,
Yes,
just-
sir, yes, sir, yes, sir. Sir, now I am
We are just starting.
I could share now.
Again,
This
share
Excel.
your screen related to Excel file.
Yeah, yeah, yeah. Yes.
Now is it visible?
Is it visible now?
Yes, sir. Continue.
Yes,
Yes, sir. Continue.
Yeah, sir, this is the my adopters and non-adopters 2 category. Yield is the our objective. It is taken quintal per hectare. And before the water saving interventions, after the water saving interventions, what is their yield? The total number of farmers 128 from the adopter category, 146, right. And here it is non-adopter category. Okay. And the difference between these two, in between these two and between these adopter category, and finally difference between this adopter and non-adopter category gives our net impact. That is what in the last column I have given here. You may see from the difference, normal difference. This difference makes the adopters before how the adopters after the program interventions, what their average yield. This yield indicates the adopters before intervention of the program, what is their yield. Okay. Likewise for the control groups before and after. Okay. The difference between the final figure which I wrote here, which is the difference between these two differences. Okay, that gives you the final impact. Okay, for one floor. Likewise, for each program we can give impact. Okay, only one intervention program I have taken here. For likewise other intervention also we can have it. Okay, and that Stata could not open the Stata now. So I'm giving you the codes. Okay.
You have already given the codes.
Yes, sir.
Yes, sir.
Yeah. Yes, sir. I'll be sending, sir.
Thank you very much.
Thank you very much, sir.
Thank you very much, sir, Dr. Balasubramanian,
More time, sir.
for giving so nice presentation, is explaining all the theoretical aspects, practical Excel sheets, software in a very brief time with all possible internet issues. Thank you, sir, for from the side of organizers and participants for delivering the lecture to.
Sir,
Yeah, thank you very much, sir, for the nice
Thank you, sir.
opportunity. And thanks for the nice opportunity.
there is one question.
And
From the participant side, I'd like to know just before concluding this session, query is there because
One query, sir.
10 minutes late.
Baseline data also collected from control group pharma. It is possible or not?
control group farmers also it is collected. Then what is the next question?
Sir, there is only one question.
Okay. So
Control group farmers are included in your baseline study.
Okay.
That is must. Okay.
Okay, sir. No.
That is the baseline, which has both control and treatment.
okay, sir. Thank you very much, sir.
Yeah. Yeah. Thank you.
Then it is so.
Thank you very much, sir.
Because, sir,
Thank you, sir. Thank you, sir.
Thank you very much, sir.
Yes, sir. Yes, sir. I am leaving.
So,
Sir, Shivan, sir, sorry for that. Taking much time, sir.
There is no issue, sir. There is no issue, sir. This is common.
Yes, sir. Thank you, sir. Thank you very much, sir.
Thank you very much, sir. Thank you.
Thank you, Bala. Thank you very much.
Yes, sir.
Because we have a next lecture in this afternoon session, structure of rural employment in India using NASO and SSO data. This lecture will be taken up by Dr. Shivendra Kumar Srivastav ji. And he has already taken lecture here in this training session and may be familiar. Again, I am introducing about our expert, just to remind again.
Dr. Vikas, let us already, it's already late. Introduction में time waste मत कीजिए. I think I've already been introduced to this.
So you may be familiar with Dr. Shiven Kumar Srivastava, and now I invite him to deliver his important talk on structure of rural employment.
And don't you give some time, 5 minutes gap to participants between two lectures?
The time?
मैं कह रहा हूँ 2 lectures के बीच में time gap नहीं देते हैं, ये होना चाहिए ना थोड़ा सा.
हाँ, ये issue है sir, because these people some issue was there, that's why we have got late. Otherwise, we could give some time.
Anyways, thank you so much. How much time I have?
Well, it is up to 5:30. It's up to you, sir.
5:30. Okay, 1.5 hours. So, thank you very much, Dr. Vikas, Dilip, Dr. Subhashan sir, and others for inviting me. I hope you all are having a good time and learning a glimpse of many technologies, methods, and new issues in agriculture, rural development, and other things. So today's lecture is not on hands-on practice or some specific methodology, but I've been asked to brief you about the changes in the rural economy, changes in the rural employment, what are the labor related issues in agriculture, that how we can see that how the things are changing over a period of time in relation to employment and its implications, what are its implications on agriculture. What I have thought that we can discuss these things very informally, and purpose is that can we identify some of the emerging issues in the area of rural economic transformation and employment, so that we can do some research work on these issues, which we can discuss in this one and a half hours. So I request all of you to be as interactive as possible, because that way I will also gain some insights from your experience. Correct. So I can see that this is the last lecture of the day, so you might be tired as well. But let us discuss few aspects, and I hope that I can create some interest on these issues. Let me share my PPT. Before I start, I would like to know if anybody is working for his or her thesis or the research work on labor and employment related issues. Anyone who is working something? No one. Anyone who is working on rural transformations? Anyone who has worked on cost of cultivation data?
No, sir.
How many of them are active actually? I don't know. I can't believe that persons have not used the cost of cultivation data, labor, and other things. Anyone has worked on women related issues in agriculture?
So there are messages in.
You can interact on audio as well. Dilip, I hope that everyone is available in panel.
Not everyone, sir. Some people are in panelists, some are attendee mode. Because our capacity only 100 people now.
Oh, I can see Dr. Latika Sharma, madam. She has worked on employment in Rajasthan. Okay.
And Chandresh
Good afternoon, madam. I'm happy to see you. And then Chandresh Guleria has worked on cost of cultivation. Also on cost of cultivation data, of course, you have worked on those things. Okay. I don't have audio. No problem, madam. Okay, so I can see some prior experience on these related issues. Uh, and we all know that agriculture, whenever we talk about agriculture, we need to talk in perspectives of how the overall economy is changing, how the things are taking place, how the new things are emerging, how the agriculture and non-agriculture are interacting with each other. And economic development always says that as the development happens, that share of agriculture in national GDP or in employment should decline, and the share of non-agriculture should increase, so that these are some of the desirable indicators for economic development. But of course, when there will be a decline in the labor force in agriculture, and it will have some definite implications. Obviously, for performing the agricultural operations, particularly during the peak hours, or the wages, the economic scarcity happens, which leads to the increase in wages, and increase in wages has some definite implications on the farm profitability through increase in cost of cultivation, and this reduces the farmers' income and those type of things. So we can have many linkages, many connects between the changes in rural economy, then changes in rural employment, and then its implications on agriculture, whether farm mechanization is desirable, whether it is taking place at a desired rate or not, whether we are benefiting from farm mechanization or not. So there are many several issues. So my purpose is that I will be only providing you some of the empirical evidences. So whatever we will be talking in terms of estimates, data, which has been collected by the National Sample Survey, employment and unemployment surveys, which is frequently collected. Earlier they used to do survey on a quinquennial basis, and now it has been replaced by periodic labor force surveys, which is conducted on annual basis. So we will be seeing that what are the emerging trends out of these surveys, and from those empirical evidences, we will be deriving our implications on different aspects of that. So that's all we'll be doing that. I have used data on cost of cultivation on for my PhD work. If any one of you can speak, that will be better, because I may otherwise lose some of the comments. So before we start, I would like to give a little background that we all know it very, very well that Indian society and the economy has two distinct categories. We have the rural India, and then we have the urban India. And as we are developing the if you can mute yourself, that will be better. So over a period of time, we are becoming more and more urban actually. That amenities are improving, population is being classified as the urban population, infrastructure is developing, income is improving, lifestyle is changing. And so we say this, now we have the two distinct categories. One is the rural and second is the urban. But still, if you see the empirical data, you will clearly come to know that still the rural areas are predominant in India. So you take for example the indicator like population or the workforce or the share in national output or the future projected population also. Okay. So about 69% of the India's population for the census based on census 2011, 70% of the population resides in still areas which are classified as rural areas. Similarly, about 71% of the total workforce in the country resides in rural area. And the rural areas contributes about 47%, about half of the national output in terms of the production and those type of things. For all the, not only agriculture, but both agriculture and non-agricultural products, it is being produced in rural areas. And United Nations actually projected that even up to the year 2050, the rural population will be about 50%, about half of the population will be living in the rural areas in India. And after that, the share of urban area will increase. So we have a fair evidence that, or we have the sufficient evidences that that still we have the rural activity as a predominant activity in the country. And that's why it is utmost important that we need to make rural areas stronger. Why stronger? Because if you see some other indicators like in terms of worker productivity, so a study conducted by us showed that a worker and an average worker working in urban areas work almost 3 times higher or earns almost 3 times higher as compared to the a worker working in the rural areas. And that's why there is a lots of rural urban disparity in income. And because of that higher earning in the urban area, there is an unplanned rural to urban migration. And these things necessitates that somewhere we need to make rural economy a stronger economy, so that can we generate those employment, a productive employment rather, in rural area itself or not, so that we can check those unplanned migration towards the urban areas. And there are so many studies have been taken place, and there is a almost consensus among those persons and the scholars that employment diversification from agriculture to non-agriculture is a major source of improving worker productivity in the rural areas. So recommendation is there. Can we shift what we say is workers from agriculture towards the non-farm sectors, which are, because non-farm sector provides better income. So if we need to improve the income or worker productivity in the rural areas, probably the employment diversification is a important aspect. And that's why this area is a very important area. And if any one of you wants to do any work that will be uh, uh, an interesting one. I see one question is that in rural areas have big problem of disgust unemployment. That's true, Sunil, because and that's why probably due to this discussed employment, we want that workers should be employed in or productively employed in an activity where they should employ and get the better employment opportunities. And that's why the agriculture is the sector where discussed employment is the uh, uh, large. So we need to shift workers from agriculture to non-agriculture. So in fact, that only we'll be discussing in the next 1 month, 1 month, sorry, 1 hour. And we'll see it has some definite implications, and what are those implications. So in fact, when we say this employment diversification is must, it does not mean it is not taking place. In fact, all the indicators says that most of the study says that such transition, but employment diversification is slower. It is taking place, but at a slow speed as compared to the transitions in rural output. I will share. I will show some evidences on that so that you will get more clarity. It means that things are taking place, but at a slower rate. So, can we accelerate the employment diversification? And if we can, what are the sources for that? What are the way out for accelerating those employment diversification? So when we see this interesting questions will arise that what are the changes happening in rural labor market, or the rural employment or something. So we can see this whether farm family members are withdrawing from agriculture or not. So this, once the economic development takes place, the first thing an agriculture household does is that they withdraw their family members from the cultivation or the agriculture, and they hire more and more labor. So they sort of uh, withdraw or their family members. So whether family members are withdrawing from agriculture or not. So that's an important question, and we need some evidences on that. So are the changes in the rural labor markets are taking place primarily because of agriculture? Because in the rural area, or even in both the rural and urban area, the agriculture generates the least income. Probably, if we leave about this labor and other things. So and that's why we say this whether the changes or employment diversification or any other things, is it only due to the driven by agriculture or not? And then the big question is always it's been asked that whether feminization is taking place. So most of the time we say this implies that workforce participation by female is increasing. There are actually the contrary evidences in the literature. Few says that feminization is increasing in agriculture, but if you see the employment data from representative survey, which shows that there is a defeminization actually taking place. So we need to have some concrete evidences based on some well planned studies. So can we do those type of studies? And then, as I said, this once the labor is shifting from agriculture, then it has some implications. It creates the physical scarcity of labor for agriculture, and that affects the farm operations, particularly during the peak season of the agriculture. And then it also creates sometimes the economic scarcity. It means that, but economic scarcity means the labors are available for the work, but they are demanding more wages. Okay, so the wage rates are increasing. Maybe if the farmers can pay more wages, then they can get the labor, but not under less wages or something. So once they have to pay more wages, it will automatically inflate the labor cost and then cost of cultivation, and then it may lead to the inflationary pressure in the economy. So those things are we need to manage these things. Recently, one more point I want to highlight is that due to the COVID, you all must have seen the how the lockdown has affected the labor market. People started going back from urban cities to the rural, their native places, and then there were lots of disruption in the due to the movement lockdown. There are lots of disruptions in the labor market took place. So, can we do a study, or can we analyze these issues that whether there was a short run disequilibrium in the labor market or not due to the reverse migration to rural areas, and then due to the rural to rural movement of seasonal labor? What does it mean by the rural to rural movement? These few states like Haryana, Punjab, and those places where during the harvesting season of, let's say, paddy, or the sowing season of wheat, the labor comes from other states like Bihar on contract basis. So because of lockdown, it actually disrupted and this checked the rural to rural movement of those seasonal labor. So what was that impact? So can we do and study those type of things? So we try to do some aspects of that using some quick studies, and I will be sharing those empirical evidences. I saw one raised hand. In case any question is there, you please interrupt in between. Any question? Okay. So based on these things, what I have planned to share the empirical evidences basically, which we have generated from National Account Statistics and National Employment Surveys. First on what is the contribution of rural areas in national economy and employment, as I showed some of the indicators like population, workforce, national output. We'll do we'll show some more evidences on that. and then we'll see what is the growth pattern and what are the transitions in rural output and employment, and then what are its impact or if it's not impact, what are its implications on the withdrawal of agricultural labor and farm economy. So there are some things which you should know actually that before you plan for some work on this particular aspects. And can we evaluate the differential effect of COVID-led changes in labor supply on farm economy in labor deficit and labor surplus states? Specifically, why I said two type of states, labor deficit and labor surplus, because those are the states like Eastern India, like Bihar, Odisha, Assam, where we have excess labor, and those labor comes to the states like Punjab, Haryana, where we do not have those type of cheap availability of labor. So what happened to those two type of categories in terms of that wages and other things when the lockdown occurred due to the COVID in 2020 or something? So those things will be to that. Effect of farm mechanization in farm sector employment. Of course, I have this point, Mr. Arvind, that how farm mechanization is influencing and means helping us to cope up with the changes in the labor scarcity. But I have one interesting finding on this farm mechanization, and at the end of the presentation, I would like to discuss this thing. So the first aspect is that the share of rural areas, means what is the contribution of rural areas in total NDP and workforce. So if you see the long run changes using the data from 1970 to 2011, you may think that why I am showing up only up to 2011. So there is one limitation I would like to tell you, because you may also face the same thing when if you are planning to go for some research only for the rural areas. But before that, let me show you that, tell you that during the 1970s, rural areas used to contribute about 62% share in the total output in the country. Means out of total output produced in the country, about 62% used to be produced in rural areas, and about 84% of the workforce used to be engaged in rural areas. It means that only 16% of the total workforce were living or residing or working in the urban area, and rest all were working in the rural areas. Productivity, it of course was less, because 84% population used to produce only 62% of the NDP for the output. So of course the urban areas were more productive. So there you has to be some migration from low productive regions to the high productive regions, and because of that, you see this share of rural areas in NDP started declining, as well as share of workforce also started declining. But the rate or the pace is totally different. The by the year by 90 to 1999 2000, or about by the year to 2000, that urban areas actually outpaced the rural areas in terms of its contribution in output. So it means that about more than 50% of the output used to be produced in urban areas in by the year 2000. But if you see the workforce, still 76% of the workforce was living in the rural area. It has some implications actually. It shows that the output was increasing, but without increase in the labor or the employment, particularly in the urban areas. It shows that there must be some tax of labor used to be saved by in the production process. So output increase, productivity increase, but we could not create the more jobs in the urban areas, because we could produce more from less labor force, which is good also from economic development. We should always try to improve and raise the worker productivity. So by the year 2011-12, about 46% share or 47% of the output used to be produced in rural area, but about 71% of the workforce lives in rural. And that's why it is very important that we need to plan carefully, and we need to accelerate employment diversification. Okay. So this one thing. Why I have taken data only up to the year 2011, because you know this national account statistics is publishes net domestic product by rural and urban also, but they produce those estimates with base year is changed. So this recent base year for current price or the constant price is for the year 2011-12. After 11-12, no base has been changed. So we do not have any data after the year 2011-12 on the output side, means net domestic products, rural and urban, separate data we do not have. So this is the one limitation. So if you are planning for any analysis, you should know before you think that, because it's sort of outdated sort of thing. But in terms of employment, we have this recent forms also. So here you can see the gap in the rural share in employment and income has widened over a period of time. It means that economic theory says that it is good to see the declining share of rural areas in the output and workforce, but there is a deviation in the decline in the share of output and in the workforce. So that actually gap should decline over a period of time, but that could not, and that is a problem in the employment sector in the rural areas. Even you will find interesting to note that, of course, it's a well-known fact that almost 95% of the total output in agriculture as well as employment in agriculture, they are employed in the rural area. So, of course, agriculture is a rural activity. So, almost everything is produced in rural areas only. In terms of non-agriculture, that you can see that about 1/3 or 35% of the total non-agriculture output in the country is produced in agriculture as an aggregate, I'm saying, and about 48% means about half of the workforce is engaged in non-agriculture. If you further disaggregate non-agriculture among the manufacturing, construction, or the services sector, you can see that in manufacturing sector, about 50% of the total manufacturing output in the India are manufactured in rural areas, but its share is less. Employment share in employment is less. And over a period of time, you can see that earlier in 1970s, only 25% of the manufacturing output was in rural area, but it has increased to almost double, about 51%. So this has some implication. It means that most of the manufacturing plants are being constructed. It may be because of many reasons, because of the cheaper availability of labor, cheaper availability of inputs, some environmental laws that many of the industries cannot be established in urban areas, pollution and those type of things. So they are shifting their base towards the rural areas, but there is no change taking place in the employment. So almost same 50% share, that there has to increase in employment share also. So that is not taking place, and this is the worrisome. This is the jobless growth in the manufacturing sector. It means that output is increasing, but employment is not increasing. So in a country like India, where we have the, as someone said, this discussed employment, we have the excess labor. So labor intensive industry and manufacturing industry is set a labor intensive industry. So even labor intensive industry is not being able to deploy more labor in that. So this is a problem. You take, for example, other non-farm sector, that is the construction sector, which is also has increased share of construction sector has increased. It means that rural area construction activities are taking place at a higher rate as compared to the urban areas. And you see the employment share has increased, and it is higher than the increase in the output. So it means that most of the persons who are leaving agriculture and joining non-farm sectors, they are not going to manufacturing sector, but they are going to the construction sector over a period of time. It means that an agricultural labor, if he is quitting job of cultivation or something, then he is going to the real estate and working as a casual labor or something. So that is a point or issue emerges, that whether he is getting productively employed, whether he is skillfully employed or not. Because construction worker, what is the working conditions in the construction sector, that is not well better as compared to even agriculture or something. So whether construction sector can sustain these type of things, so which is a matter of discussion and consideration. Services sector share has declined in terms of its output, means over a period of time, services sectors like IT, hotel, transport, and all those type of things are becoming more urban centric, and similarly, its share in employment is also declining. So why I am saying is that in the once we need to develop some strategies for rural and for agriculture sector, we need to see what are the changes taking place in other sectors also. Because if we see this, we need to reduce the excess labor in agriculture. Then we need to see that where they need to be deployed, whether manufacturing, construction, and services sector. So if we see this, if we cannot, if manufacturing sector is not able to employ incoming labor, so what is the problem? Whether it is the skill related issues or some other type of issues. So skill related means most of the rural workers are largely unskilled. So because of unskilledness, they are not able to get productive employment in manufacturing, but they are landing up in the construction sector. So those are the few things which we need to take into account. This is similarly the manufacturing sector, which I showed here, that how the its share has increased from 25 to 51. So you can see that a drastic improvement in the share of rural in rural share in manufacturing sector output has increased, almost doubled, but employment has not increased. In fact, it's almost stagnant. So that's how we say this. Either manufacturing jobs are moving in urban areas or staying in urban areas. It means that sometimes it happens that you also might have noticed that when a industry or the factory is being constructed in rural areas, workers don't reside here, or what say supervisors and those type of person, they don't supervise live there in the rural area. They do commute from urban nearby peri-urban or the urban to the rural area. So that's why they are not counted as employees of the rural areas or something. So there is some counting problem also. So that's the one of the issue in manufacturing sector. Now, recently after 2011-12, as I said this, we have the latest data. In fact, I would like to inform you that Government of India has initiated periodic labor force survey, where every year data is being collected on different aspects of employment and unemployment. So we now have the latest data up to the year 2019, 20, 17, 18, and 19 annual. Earlier, they used to be quinquennial survey every 5 years, and now they have the annual surveys. So there we can see some of the ratios, like what is the worker population ratio, which means that out of total population, how many workers are there. So there, if we divide, we see the contribution of rural in the total workforce. You can see this. The WPR is declining over a period of time. It means that over a period of time, this workers are increasing, but population is increasing more than the workforce. So that's why the workforce population ratio is decreasing over a period of time. Rural share in total workforce shows that almost everything in agriculture is produced in rural, but in non-farm sector about 50%, means whatever trend we saw in the last slide up to the 2011, almost same trend is continued for the recent years also. And this total workforce, about 70% of the total India's workforce is engaged in rural areas only. So these are a few of the evidences which shows that how the activities are distributed are taking place in the rural areas. Any observation or any question? Nothing. Okay. So let us come to the second issue which I listed in the start is that what is the growth rate in output as well as employment in different subsectors like agriculture. You see this how the agriculture has grown in over a period of time. Or for example, between 1970-71 to 94, agriculture grew at annual rate of about 2.5%. But in the post-liberalization, means after 1991 to 2004, the growth rate in agriculture actually decelerated. It increased only 1.8%. But if you see this non-agriculture growth rate, which has increased by 7% or 8% rather. Okay. So you can clearly say this, see that in terms of output, the growth in agriculture is decelerated between 93 to 2004 as compared to 71 to 93 4. But agriculture, it has accelerated. And even still in the recent years, 2004 to 11-12, it has increased at 9%. Agriculture also, it has increased by 4.2%. So we can see this after the year 2004-5, growth in agriculture has increased significantly, and it is almost, but it is still almost half of the growth in non-agriculture sector in the rural areas. Few more important insights you can see this. If you see the manufacturing industry growth has increased at a very significant higher rate, like 5% and then 8% and then 15% per annum between 2004, 5 and 11, 12. So we can see a lots of improvement in manufacturing output. But if you see the employment, that employment is decelerating over a period of time. It means that it was 3 increase at 4%, then only 3% in the recent year. It is almost nil. No increase in employment in the manufacturing and every increase in the output. So it shows that somewhere we are missing the agenda of employment creating in the manufacturing sector, maybe by deploying the more capital intensive industries or something. So that has to be considered. In case of construction, you can see this some contrary trends are taking place. Of course, these growth rates are accelerating, but at the same time, employment is also accelerating in construction sector. So you can see this construction sector employment workforce are engaged primarily in construction sector, and so if you see from agriculture, the workforce in agriculture is declining drastically. Means earlier it was 2% and then decelerated, and now recent year after 2004-5 to 11-12, it decreased by about 2% or something. So it shows that persons or workers are shifting from probably agriculture to non-farm sectors, and within the non-farm sectors, mainly the persons are going to the construction sector. So I did one calculation which shows that out of the total workforce which are moving and joining non-farm sectors, about 75% are joining construction sector and rest others manufacturing and services sector. So the construction sector is a what we say boom is taking place in the construction sector as the data shows. Agriculture sector shows the withdrawal of cultivators and agricultural laborers. So this is a plus point if you talk in terms of economic development, but it has some implications as well. So I will give more picture on employment using the latest data also. So because of that, what we say this differential growth among the sectors, you can clearly say that see this how the share of agriculture in total employment is taking this employment is sorry output is declining. You know this earlier out of total rural output. Let us not consider national output. Let us see only the rural economy, that within the rural output, how the rural output is distributed among the industries like subsectors. So out of total rural output, about 72% was agriculture in 70s, which declined to 39%. So you must be thinking that we always say this agriculture, that India is an agriculturally dominated country. But even data shows that even the rural areas, in terms of output, agriculture is no more a dominant occupation in the rural areas. If you see the output or something, it's only that agriculture contributes only 39 or 40% of the total rural output. Others are by manufacturing, construction, and the services sector. So it is a non-farm or a non-agriculture activities which are constituting a dominant share in the rural output, but only in terms of output. If you see the employment, it is still the agriculture where we have lots of engagement in terms of workforce. So earlier it was 85%, but it's still the 64%. So the 64% of the total workforce, the issue is that 64% of the total workforce who are engaged in agriculture, they contribute only 40% of the total rural output. And that is probably what someone has said there, we have a disgust employment, or we have a less productive employment, or we have the excess dependency on the agriculture sector. And that has to be reduced either by moving the workers outside agriculture, or by increasing the income of the agriculture by improving the productivity, value addition, and those type of things. So those are the two approaches for the as far as planning and policy is concerned. So the takeaway message is that agriculture, we should not say agriculture is the predominant activity in rural area. It is not in terms of output, but still agriculture engages lots of labor, even more than 60%. So we have the excess dependency on agriculture. So we have few long run trends also, including the recent data. You can see this lots of time we say this, we should do some gender related studies and see that how the things are taking place, whether who are the main constituents, whether it's a male workforce dominated or female workforce dominated. So you can see this WPR, which is the workforce participation rate, which shows that in the year 1972, about 50% of the total male population used to work actually. You may go tomorrow. So about 55% of the total male population used to work. So WPR was about 50%, but female only 32% of the female population used to work in 1972. So if we translate in terms of composition, so we had about 191 million workforce in rural areas in the 1972. It means that 19 crore workers were there in rural areas, out of which 64% were male and only 36% were female, because participation of male in the workforce is much higher as compared to the female. So what happened over a period of time? Over a period of time, male participation was almost stagnant, about 45, 44. Sometime it reduced to 52. But female participation, you can see there is a drastic decline in the female participation after the 2004. Okay, till that it was almost stagnant. Between 2004 and 11, female workforce participation declined from 33 to 25%, due to which the that share of female in total workforce declined to from 36 to 30. It means that these are the signs of defeminization in agriculture. Even after the 11-12, if you see the trend using the PLFS NSS PLFS service, by the time 2017-18, female workforce further declined from 25% to 18%. And that's why its share in agriculture decline, its share in total workforce declined to 24%. So you can see that we have the empirical evidences at the macro level, which shows that we are seeing a defeminizing trend in the agriculture. Rural workforce. In the recent 2 years, you can see there is some upward movement, like 17-18 to 18-19, it has increased marginally, but between 18-19 and the recent data shows that female workforce has increased significantly, and it has reached to the level of 2011-12, about 24%. We need to really see that what happened between 2018 and 19, that data has captured that WPR has increased from 19% to 24% in case of female. I would say that it is still less 24%, but this change is very, very striking. But I do not know the reason why it happened, whether it is a problem of data, that data is wrong, or there are some phenomena which is taking place in the rural areas because of that female participation in the rural force is increasing. So for that purpose, I believe that we need to do some ground related studies at the ground at the rural area, some primary surveys, and try to find out that what are the reasons that why the female participation is increasing, whether it is because of distress, because there is a phenomena that once there is a distress in the family, that the female comes out and they start working, particularly in the rural district, or it is because of development, whether female are getting more better job as compared to male, and so they are coming forward, whether they are getting jobs in MG Narega work, or they are getting more jobs in some other activities which are promoted by the government, some self-help group and those type of things, whether something is really picking up or not. So those answers can only be uh, 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 that that has to be searched actually using the primary survey. So this is the two trend actually, where you can see this. There is a defeminizing trend at a broader level, but last 1 year, that female participation has increased significantly, and I do not know the reason of that why it has increased. So we should also see some trends and compare between the rural and urban areas. Within rural, that agriculture and non-agriculture, and see that why the things are taking place and what are the broader trends actually. So these are the numbers which I have estimated between 93 to 2019 using the NSS employment surveys, then census population, and then the PLFS surveys. So here you can see this between 93 and 2004, actually the agriculture workforce was increased by about 1%. But 2004 to 2011, the workforce in agriculture declined at about 20, how much? About 22 million, means 2 crore agriculture workers left agriculture between 2004 and 11. So I would like to tell you that this is the first time in the history of independent India that in absolute numbers the workers have withdrawn the agriculture. Even you can see the census data. I will show further that the absolute numbers have declined between 2001 and 2011 census. So that people say it is a good point, which shows that people are leaving agriculture, particularly from the point of view that we have the over dependence on agriculture, and once that persons are leaving, the workers are leaving, which is good. Between 2011 and 17, actually they further declined, that withdrawn. So in the growth rate of decline in agriculture worker accelerated to 2.29%. If you disaggregate this decline by the female and male gender wise, you can clearly find that decline is primarily by the female workers, which has declined by more than 4% or something, and male workers, they have withdrawn by 1%, less than 1% or something. So it is the female workers who are withdrawing from agriculture, and they are leading to overall decline in the total rural workforce also, because the decline in the workforce is more or the striker or higher as compared to the increase in the non-agriculture households. So this shows two things. Once the persons are leaving agriculture, they are probably going to the non-agriculture sector. They are getting job, but not all the persons are getting job in non-agriculture. Some people are not getting the job in non-agriculture. So it is leading to the overall decline in the total workforce. There may also be a one phenomena. Many persons, many female who are withdrawing the agriculture, they might not be even joining the workforce. They might be opting to live inside the households, and because of that, total workforce availability in total rural areas are also declining. Then comes to the last, the recent period after the 2017 to 19, you can see that there is a drastic increase in the growth rate in the agriculture workforce, and the data shows it's more than 8% between these 2 years, from 188 to 222. So this is a very significantly increase in the agriculture workforce, and this increase is almost double as compared to the increase in the non-agriculture sectors. So what has happened between these 2-3 years? Does it mean that recent Indian government or many state government initiatives to attract youth and attract persons towards agriculture is working? Whether the programs are working, showing their effects that persons are taking more interest in agriculture as compared to non-agriculture, or it might also be the case that persons who are not willing to work, they are going to non-agriculture, but they are probably not getting a good work in non-agriculture, so they are getting returned to again to the agriculture sector. So based on these data, we can only draw some of the implications. We can only see that what the broader trends are showing. And if we can ground truth these survey using some primary survey, and that will be the more insightful, particularly in the employment sector and ones. So because of that transition, you can clearly see that in the rural areas that that how the share of agriculture is declining from 86% to 58%. Share of non-agriculture is increasing. But last 1 year, you can see that agriculture is growing at a higher rate as compared to the non-agriculture, and so again, share of agriculture has started increasing. So this is a point to be discussed, and further research is needed that whether it is a good point or not so good point. So if you are really interested in working on employment related data, so you will find two sources of data. One is the census, which shows that what is the economic status of the population. So they also gives an estimates on cultivators, laborers, all agriculture workers, other workers who are engaged in some productive economic activities. Then we have a specialized surveys conducted by the National Sample Survey. We say it the National Sample Survey Office. But if you see these two source of data, you will find a contrary trend. One thing is that because we have only comparison data between 2001 and 4, and corresponding to one, the available data for NSSO is 2004. So we can compare these two census and NSS, and they should be actually closer to each other. I will not say they should be exactly same, but the ratios of the workforce participation should be almost closer, so that it should give at least the same trend in that. I will not say that it should give the level of workforce should be same. It should not be the same because one is census and one is sample, but at least the trend should be same. But that could not take place because if you see the census data clearly shows that between 2001 and 2011, number of cultivators have declined by 2.6 percentage point. Both census and NSS data says that cultivators are declining between the 2001 and 11, but labors, as per the census, a number of labors have increased by 1.5 percentage points, but based on the NSS, even labors have also declined. So if you use the census data, what inference you will draw is that you will always draw that cultivators are declining, labors are increasing. So possibly cultivators are leaving job, they are not getting agriculture profitable, so they are becoming labor. So they are being converted from cultivators to the labor. And that is a distress-driven narratives which many scholars are giving and publishing in the journals. So if you use that census data, but if you use NSS data, you will find another narrative which shows that cultivators are declining, and they should decline because they are moving from agriculture to more productive non-agriculture sector, and in addition to cultivators, laborers are also declining. It means that from agriculture, both the type of workers, cultivators and labor are declining and they are moving towards non-agriculture sector. So if you see the NSF, you will see a development-led narrative. If you see the census, you will get the distress-led narrative. Which one is correct? We do not know. So that's why many people have started criticizing the quality of the data, particularly NSS or even census. Which one is correct? We do not have any idea. Sometimes it happens that definition of those indicators may also uh, uh, make it a contrary trend. So we should be careful what definition is there. So whether a worker defined in census is similarly defined as in the NSS or no. So we have found some evidences that there is some problem in the definition of the cultivators and agricultural laborers between the census and NSSO, which explains to some extent that why there is a contradiction in the trend in the census and NSS data. Any query till now? Okay. So, if I'm sure you must be aware that we have principal status, we have subsidiary status, then in NSS surveys, and then we have main workers and marginal workers in census. Main workers and principal workers are defined based on their time to which they are engaged. Time in the sense, if a person is engaged in any economic activity for more than 6 months or 180 days, they are defined as they will be given a status of principal status as in NSS or main worker as in census. And then the class of worker, we say it is marginal worker. It may always be possible a person may be employed in major time criteria basis as a main worker, but he may also do another activity for a short period of time. Okay, so he may also be classified as a marginal worker. So census defines that a worker will be a marginal worker if he is working for less than 6 months. But as per NSS, which is a specialized employment which captures the specialized employment trends, which shows that for the subsidiary worker or the marginal worker, they should be at least employed in for at least 30 days or 2 to 6 months. If a person is employed less than 30 days in an economic activity, he will not be counted as this marginal worker. But in census, even if he is deployed in any activity, even if he works for even for the 1 day, he will be called as a marginal worker. So because of that, we can see there is lots of the variation between the estimates of labors between the census and NSSO. And this thing we can estimate from the ratio of main workers to the total agriculture workers. So as per census, you can see this about 50% of the labor in the census were main workers, but in NSSO, 85% of the workers were main worker. It means that marginal workers were less in NSS and marginal workers are more in census. So from this difference, we can see this. There are at least 34% of the labor or up to 34% of labor who are actually counted as a marginal worker in the census, but they have worked at least less than 30 days in a year. And that's why census counts it as a marginal worker and their number of labors are increasing, that increases, level of worker estimates increases. But NSSO does not count those as a subsidiary activity, a workers or the marginal workers. I hope I am able to communicate that definitional issue. Main issue is that because of the difference, the variation in the different definitions of marginal worker particularly, we have some evidence that there is a discrepancy in the data of agricultural labor between census and NSS. So that discrepancy you need to take into consideration whenever you are drawing the implications. So here I'm not saying that which one is correct, census is correct or NSSO is correct. Both have adopted their own definitions, and that's why the estimates are different. So whenever you want to draw any conclusion, you should go and see that what are the definitional variations, and then only you should draw your conclusions from the data. So now recent period also you can see this, I have estimated a number of cultivators, labors and other things. So you can see this cultivators have declined, but the rate of cultivators between 2004 and 11 and 11 and 17 has decelerated between 2011 and 17. It means that of course the cultivators are leaving the job, leaving agriculture, but their rate of withdrawal has reduced between 2012, 11-12 and 17-18. So can we say that now the withdrawal trend is decelerating? And in fact, the most recently that 17, 18 and 19, the number of cultivators have increased at the rate of 9% between 17 and 18, which shows that persons are again getting attracted towards the agriculture. And this is not only related to cultivators, but also towards the agricultural labors also, because earlier labors were withdrawal of labor was increased actually 2% to 6%, but again between 17 to 19 it has number of labors have increased to 6% at the rate of 6%. So we can see this again some trend reversal in terms of number of cultivators and labor, particularly in the recent 2 to 3 years. We need to see that whether what are the reasons behind that. And female, if you see, it is primarily driven by the female members. So both in cultivators and laborers, female workers are again joining the workforce. So it is a good trend as far as feminization narrative is concerned, but we should further do some research and try to find out whether this trend is because of distress led or because of development led. I will be happy if any one of you can give your experience and answer that what may be the plausible reasons for that. So and the third part is that what are the implications of changes in the labor force in agriculture. So we can always see this because labor actually once it is withdrawing, and labor is one of the most this dominant element in the cost of cultivation. You know this. I estimated an average cost A1 plus FL using about 10 crops across the states using their weights, area weights, and could find that about 46% of the cost A1 and the family labor is constituted by the labor. So if we really need to minimize our cost, so we need to see that if we can minimize or manage the labor, so we will be successfully minimizing the cost of cultivation also. So cost of cultivation data of Directorate of Economics and Statistics says that over a period of time, both the female and male this labor use has declined, and the decline actually has accelerated at the rate of about 2.5% between 2012 and 17. So we can see the same trend which we could see in NSS survey, that cost of cultivation survey are also showing a decline in the labor use over a period of time. So this labor actually, if it is declining, it may lead to the saving in cost. We can expect that if the labor is declining because it constitute a about 50% share in cost, so cost should also decline. But what happened is, despite the decline in the labor, you can see between 2093 and 11, the cost or the real labor cost has increased. The reason was that the increase in the labor wages was much higher as compared to the decline in the labor use. So despite the labor use has declined, but labor cost, which is the multiplication of labor use, means hours multiplied by wages, is the labor cost. It has increased rather than the declining. So we could not get the advantage of declined labor use in terms of physical units, in terms of this labor cost, and because of that, average real cost actually increased from 10,000 per hectare to 15,000 per hectare. So it is an average of 10 crops over the period of time. Okay, so this is one phenomena which is taking place, that although labor use in physical use term is declining, but labor cost is still increasing over a period of time. It means that we are facing a problem of economic scarcity of labor, because real labor wages are increasing at significantly higher rate as compared to the this decline in the labor use because of farm mechanization or something. So you can still see this earlier in 93 or 2004, labor used to constitute about 38% share in cost, and by the year 2011-12, it constituted 46% share in cost. So it means that we are still not able to cope up with the economic scarcity of labor, even though the physical scarcity of labor is declining. So what may be the possible explanation for this? What may be the technical way to explain this phenomena? Why, despite the decline in the labor use, why the labor cost is increasing? So one way is that we should see the relative change in the labor use and labor price of labor or labor cost. And for that, we can use the concept of price elasticity of labor or demand elasticity of labor. So I'm sorry, I may not be able to give a hands-on training on this cost function using which you can estimate the cost demand elasticity. But if you are interested, we can some other time always discuss that how we can actually estimate this demand elasticities of inputs, and labor is taken as one of the inputs. So using this translate cost function, we can fit the estimate the demand elasticity, and this is the final demand elasticity, which shows that price elasticity of labor means it is less than 1 in all the crops, paddy, wheat, jowar, maize, and that. So it shows that overall average price elasticity of labor, it means that the response of labor use due to the increase in the or the change in wages is negative, which is obvious that it is a price elasticity, which means that when the wages will increase, labor use should decrease, and but it is inelastic. So which shows that if we increase the labor wage by 1%, use in the labor will decrease by less than 1%, so that cost of labor will increase due to the increase in the wages. Okay, so it is the inelastic demand of the labor or inelastic price elasticity which explains that why, despite the decrease in the labor use, why there is an increase in the labor cost. It is primarily because of inelastic demand of labor. So this also signifies that, and it is also a technically also we can show that we cannot substitute every operation of labor with the machine. It may be possible that we can, for example, in paddy, we can transplant the paddy using the transplanter, or some other operation we can use the machine, but not all the operations can be done by the machine. So we need to have at least some labor deployed in some farm operations, and that explains that price elasticity of labor has to be inelastic, and because it is inelastic, so when there will be an increase in the wages, it will always lead to the increase in the cost of labor. So, so that's how we need to see that if we really want to see the positive impact of changes in the agricultural labor changes or the employment changes, we need to control the wages of the labor. If you're thinking from cultivators point of view, if you're thinking from labor point of view, it means that it is always good to have more wages in that. Second aspect, that on farm mechanization, which someone asked that what is the pace of farm mechanization. So if we estimate the elasticity of substitution between labor and machine, which is the change in the ratio of labor and machine due to the change in the prices of relative prices of wages and machine. So that elasticity is inelastic. Similarly, 0.64 is the average, which shows that if there will be about 10% increase in the ratio of wage and price, it means that when the actually it is a relative change in the price and the price of labor and machine, which actually matters, not exactly only the price of labor or price of machine. Farmer will substitute labor with machine when he will find that whether now the machine is cheaper than the labor. If machine is not cheaper than the labor, if the prices, let's say, increase in the same proportion, both the price of labor and machine, so probably he may not like to substitute. Okay, so the substitution elasticity less than one means that if there is a 10% increase in the prices, relative prices of this labor and machine, it will lead to less than 1%, means only 6.4% change in the ratio of machine to labor, which in other words will lead to the increase in the share of labor in farm budget. In the simple sense, if I say farm mechanization is taking place, but farm mechanization is not completely able to substitute the labor, or at least to that extent, it will have some impact on the cost of cultivation. So because of inadequate pace of farm mechanization, that labor scarcity is taking place, or in economic sense. In other words, we need to accelerate the pace of farm mechanization, and we need to see that we should have a desirable aspects on this what we say, this substitution between the farm machinery and labor use. So policy answer is that implication is that probably somewhere we need to develop more better, what we say, more affordable farm machinery. We need to improve its accessibility at the affordable rate to the farmer, probably through institutional aspects, for example, the customizing centers and other things. The farmer should get access to machinery so that they will employ more machinery, and that's why the this economy of scale of using the machinery will increase. At present, we are not having advantage in economic terms or in terms of revenues to the or cost to the farmers. So last part is that what was the impact of lockdown during the COVID on the labor supply. So I did just a quick analysis. We estimated, we took two states, one is Punjab, which is the labor scarce state, and which where the farmers are dependent on the contractual labor, which comes from Bihar or Assam or West Bengal during the paddy harvesting and the wheat sowing. So you might remember that in March, April onwards, I think, was the lockdown in the year 2020. And after April, May, June is the period in which harvesting takes place. And after that, wheat harvesting takes place, and then paddy transplanting takes place. So that when there was a lockdown, so there was a problem in the movement of labor, probably for the quite some period. After that, they opened also, but that operation might have got affected. So based on we estimated demand elasticity of labor, and then we also estimated for Bihar, because most of the labor mainly from urban areas went back to rural also. So they might also led to increase in the supply of labor. So we can expect that there should be a decline in the wages in the local market in that. So we did a quick survey, and we found that there was about 24 to 46% increase in the wages for paddy and wheat respectively, as compared to April to June 19, as in April to June 20. But in the Bihar, we found that there was no decline in the wage rate. So we can expect that probably those urban laborers or skilled laborers who went back to rural areas, probably they did not work in agriculture. They probably might have worked in NG-Narega or some other thing. So it did not take any. It did not actually affect the wages, prevailing wages in the Bihar state. So we could not we cannot get advantage of that from farmers' point of view. But in case of Punjab, actually, it led to about 4% increase in the cost of cultivation, because total labor cost increased by 40% or 15%, but we also need to multiply with a factor, because it was only one operation which was performed in that particular period, that is the transplanting for paddy and harvesting for wheat. So that constituted about 6 to 12% share in total cost of cultivation. So total effect on cost will be about only 4%, or it's only 1% for wheat and about 5% for paddy. So this was the using the elasticity concept. Purpose is that we can use this the concepts of elasticity to explain some of the things which are taking place in the society because of some interruption, some like COVID. So this is all from my side. I only try to brief you and show some of the evidences to raise some of the issues. If you can take up some of the issues and do some primary survey based studies, so probably that will be good contribution to the literature. So thank you very much. Any questions are most welcome.
Thank you very much, sir. If any query is there regarding the topic, please inform. I request the participants, you may write also in the chat box. So,
No query, yeah? It means that I can't have any influence then.
no, sir, they may not be writing, maybe because your explanation has made very clear. Slides were very clear, explaining the things from the starting to current status. So these were very clear explanation from our expert. So we have not got any other query from the participant side. So at the end, I am thanking our expert